Hello everybody, welcome to funwithphysics.com. I'm Ben, and let's jump right into this experiment. If this is your first time on funwithphysics.com, I'm going to film out a bunch of experiments, show you how to do them, but if you don't want to watch the video, if you want to read instead, instructions will be down below the video. Today we're going to be talking about a very common household item. It can be used in electronics, or it can be used to pin stuff to the fridge, like that cool drawing of a dinosaur you made in school or work. We're talking about magnets. Now there are two main types of magnets that we deal with in our day-to-day life. There are permanent magnets, which are the types that you would find on your fridge, and then there are electromagnets. First, we're going to talk about permanent magnets to give us a basis of what magnets are in general. There are a few different factors at the atomic level of a material that will determine whether or not it is magnetic. And we're going to start with the lowest level, which is the electrons of the atom. You can visualize the electrons of the atom to be their own small magnets, as in they have a north and a south pole. Now, if the atom has enough electrons to fill all of its valence shells, these electrons will start to pair up, and their poles will flip as they cancel out each other's magnetic fields, which means they won't have any magnetic properties. If, however, the atom doesn't have enough electrons to fill its valence shells, then they'll have lone pairs of electrons that will align their poles in the same direction and add to the overall magnetic field, making the atom magnetic. If the atom is magnetic, then we can also visualize that as a small magnet with a north and south pole. And then we have to consider all the other atoms in that material. If the majority of the magnetic atoms within the material have their poles facing in the same way, this will create a magnetic material as a whole. Whereas if all the poles are in a random direction and overall cancel each other out, this will give you a non-magnetic material. That's why you can find bars of iron which are magnets and bars of iron which are just regular iron with no magnetic properties. The magnets have all their magnetic atoms pointing in the same direction, giving it a magnetic field, whereas there's no alignment for the bar of iron, which means it's not magnetic. These types of materials with all their magnetic atoms facing in the same direction is what we call a permanent magnet, because there's no external charge or manipulation to keep them aligned. It's just natural. The other type of magnet that I'm going to show you how to make today is called an electromagnet. Now the cool part about electromagnets is that they can be turned on and off. You can choose how powerful they are, and they can be made out of any ferrous material, even if it's not already magnetic. Ferrous materials are materials such as iron, nickel, and cobalt, for example. To make this electromagnet, we need a ferrous material that isn't already magnetic. This can be just a regular bar of iron. As we talked about earlier, by this material being non-magnetic, it just means that the magnetic atoms of the material aren't aligned, therefore create no magnetic field in the material. To turn this non-magnetic material into a magnet, all we have to do is induce a magnetic current into the material, and all the poles of the atoms will line along that and create an overall magnetic field within the material. The larger the magnetic field being induced into the material, the more atoms that are going to align, creating an even stronger electromagnet. That's why we can manipulate how strong our electromagnets are. Making that magnetic field for the poles to align to is actually very simple. All we need to do is wrap a conducting wire around the material and then push a current through it. This finally brings us to today's project, which is going to be an electromagnet. It's a very simple design. All you need is a ferrous material. I'm using iron here, a conducting wire, and a big old battery. Now typically I would like to show you how I make this, but I already wrapped it before the video to make sure it worked, and I don't want to pull it apart because it looks like it's probably going to make a mess. Now for the conducting wire of my electromagnet, I just use magnet wire. It's very thin copper wire coated in enamel, and you can use it to wrap many times around your ferrous material, which is actually very important, the amount of times you wrap it. For the ferrous material, I used an iron bar, which you can pretty much find at any hardware store. It's really not terribly difficult to find, but you can also use something such as a nail or a bolt, as long as it's a ferrous material. Now you can make an electromagnet by just wrapping a conducting wire around a ferrous material, and it's not too specific and it'll usually work, but if you want to make stronger ones, there's a few points that you have to keep in mind. You need to keep in mind that the amount of coils that you make with the conducting wire as you're making the electromagnet is actually important. The more coils you have, the more powerful the magnet's going to be. Another way to make it more powerful is pay attention to how close the gaps are between each of the coils. You want to make sure that the gaps between them are as small as possible to get a more powerful electromagnet. The last two factors that manipulate the strength of the electromagnet are the surface area of the conducting wire. So a thicker wire would mean a larger surface area, which would result in a stronger electromagnet, and the current of your power source. A larger current would mean a larger induced magnetic field, which will result in a stronger electromagnet. One thing to keep in mind, if you use enameled magnet wire, just make sure you sand off the ends to get that enamel coating off so that you can connect it to your power source. I haven't experimented much with different batteries on these electromagnets, but what I do know is that I used a AA, and the wires will get pretty warm when you hold them at the top, so I'd recommend not doing that. The D battery seems to be fairly good, never overheats, and you can hold the wires there forever and you're never going to feel like you need to drop it. So to test and make sure that the electromagnet works, we're just going to take some paper clips here. Without the battery on it, nothing happens. So we just take the electromagnet and connect it to the battery here, and we test it on the paper clips again. There we go. And if we cut out the induced magnetic fields, it goes back to being non-magnetic. And that will do it for today's video. If you're not on funwithphysics.com watching this right now, you should head on over there. There's a lot more experiments like these, and have fun with physics.